In this video, we will talk about overfitting and underfitting in machine learning. So let us take an example and discuss this concept. So we have a dependent variable y, and we have, let's take only one independent variable for illustration. We have one independent variable x1. And I have drawn the points that we have. The points are represented in black. So these are the points that we have. And I have drawn two models here. One is the blue model and one is a red model. So if I ask a question, which of these models is better and will perform better? So what would the answer be? The answer to that question will be the blue model. Without any doubts, it is the blue model which will perform better. Now why would the blue model perform better than the red model? Now this is a little confusing to understand at the beginning, because we can see that the red model, so remember in supervised learning our task is to find the function f, and we can clearly see that the red model, the red function almost always passes through the points. So if we talk about errors, if we talk about the errors that the red model is making, it is almost zero, whereas the blue model definitely has some errors. So if I plot the errors of the blue model, so these are the errors, these values are the errors. So some errors are positive, some are negative, but it definitely has some errors. Whereas the red model almost passes through all the points and the error is zero. But still I say that the blue model is better. Why? This is because any machine learning algorithm, any algorithm or any function that we come up with is used for future prediction, is used for extrapolating to a data which the model has not seen before. So remember, we had splitted our data into training and the test data. So we build the model on the training data and then we apply the model on the test data, and the accuracy on the test data is what validates the goodness of your model, not the accuracy on the training data. So in this case, we can see that the red model, it takes a very complex shape, and though the error is zero, but it has a very complex shape. Now what would be the drawback of this complex shape? The drawback is that it will not generalize well on new data points. On the future data points or on the test data, this might not generalize well. So where would the test data points be? The test data points will be similar to the trained data points. It might be anywhere close to the trained data point. So it might be, let's say, here, it might be here, it might be here, 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 or here. Now if you see the test data points, you see the red line definitely makes a huge error on the test data points. Though it makes zero error on the trained data, on the test data it fails miserably. Whereas if you talk about the blue line definitely has some error on the training data points and also some errors on the test data points, but the errors will be smaller in this case because it is a simple line. It almost touches all the data points but never has an error of zero. So even in the test data, it will almost touch the data points but will never have an error of zero. So this kind of complex models are known as overfit models. The red model here definitely is a overfitting model, which is too complex, and though it would have a smaller error on the test data, on the trained data, though the red model would have a smaller error on the test data, on the trained data it would fail miserably on the test data. So this is the concept of overfitting. How do we identify if our model has overfit? So this is one of the reasons why we split the data into train and test. If your model performs well on the trained data but fails on the test data, that means your model has overfit. So this is an indication of an overfit model, if your model performs well on trained data but fails on the test data. Whereas if a model performs well on the trained data as well as on the test data, it means your model is not an overfit model and it's a fair model. Now opposite to overfitting is a concept called underfitting. So let's discuss that as well. So what is underfitting? As the word suggests, it is an overly simple model. Overfitting is a complex model. Similarly, underfitting is a simple model. Now remember, we talked about the baseline model in the linear regression model. module. So what is a baseline model in this case? This is a regression problem. So the baseline model would always predict the average of the dependent variable. So if I draw the equation of the baseline model in this case, it would look something like this. So this would be how the baseline model would look like. So no matter what values of x1 you give, a baseline model will always predict the average of the dependent variable. Now this is what is an underfitting model. So this is a very simple model, and obviously it will not perform good on either the trained data or the test data. So a baseline model or a underfitting model. So this is, let me write it down, this is a overfitting model, and similarly this is a good model, and I can have which performs poor on trained data and poor on test data as well. This is a underfit model. So baseline model is an underfit model. It does not perform well on either data sets. So this is there is a trade-off between underfitting and overfitting, and we try to be somewhere in the middle. There is a sweet spot always in the middle, and we try to find that sweet spot by using a process called cross validation, which we will see in a later module. But you can also find that sweet spot by checking on the test data. How is your model performing on your test data, and varying the parameters in your model. So if you find that your model is failing on your test data, you go back to your training data set and retrain your model and repeat the process until you get a good accuracy on both train and test data. So this is the concept of overfitting, a very important concept. So please make sure you are comfortable with this. We will talk about this a lot in the future modules.